Hi everyone, welcome back. In this video, we're going to take a look at systems of equations. We'll define what a system of equations is. We will look at how to solve a system of equations specifically by graphing in this video. Okay, so a system of equations just means a set of equations. For example, two equations. We might have y equals x plus 3 and y equals negative x plus 6, something like this. This is called a system of equations. And before we talk more about systems of equations, I want to think back to solutions to linear equations. So the question right now is, what does it mean for a point to be a solution to a linear equation? To be a solution to a linear equation. For example, if we have the equation y equals x plus 2, and we have the point 1, 3, what does it mean for this point to be a solution to that equation? Well, what it means is that when we plug in those two values for x and y, it satisfies the equation. So a solution just means it satisfies the equation or makes the equation true. So if we plug in 3 for y, plug in 1 for x, we get 3 equals 3, which is true. So when looking at an equation, a point is a solution to a linear equation if it satisfies that equation. We can also think about this graphically. So if we have a graph of y equals x plus 2, which looks like this, any solution is going to be a point on this line. For example, 1, 3 is on this line. We could look at any other point on this line, negative 2, 0, and that's another solution to our equation. Negative 2 is equal to, 0 is equal to negative 2 plus 2. That satisfies our equation. So solutions to linear equations satisfy the equation. They are also points on the line of that equation. Now we're going to take a look at a system of equations. Scroll down a bit. Okay, so as I mentioned earlier, a system of equations just means we have more than one. So usually we'll be looking at 2. And in Algebra 1, we're just going to look at linear equations. So we're given 2 linear equations. And our task when solving a system of equations is to find the solution. In other words, the point that satisfies or is a solution of both equations. So we'll be given 2 equations, and our task is to find the solution or the point that satisfies both of them. Let's take a look at an example. Let's say we have y equals 2x plus 1, and we also have y equals negative x plus 7. So we have 2 equations. We're trying to find the x and y value that works for both equations. So we could try and think of this as kind of like a puzzle. We're trying to solve the puzzle. What is our x and y value? Well, one thing we know is that the x and y value is going to be a point on both lines. If it's a solution to both equations, then it is going to be on or be a point on both of the lines. In other words, it's going to be the point where the lines intersect. So our intersection point. So for example, let's pull up a graph. Our first line is y equals 2x plus 1. So we start at 1, and then we have a slope of 2. So just like that. Our second line is going to be y equals negative x plus 6. So negative x plus 7, start at 7, and then we go down 1 to the right one. So just like that. Okay, so we have these 2 lines, not the straightest lines, but still 2 lines. And we're trying to find the intersection point, which we can clearly see on our graph is right here. Our intersection point is at 2, 5. What that means is that this point lies on both of the lines. In other words, it's a solution to both equations. And we can double check that. If we look at our first equation, does 5 equal 2 times 2 plus 1? Yeah, we get 4 plus 1, which is 5. Great. for our second equation, does 5 equal -2 plus 7? Yeah, 7 minus 2 is 5. 5 equals 5. Great, it satisfies both equations, so our solution is 2, 5. Another way to write the solution is x is equal to 2 and y is equal to 5. When we write our solutions to systems of equations, it's really important that we write two numbers. In the past, when we solve equations, sometimes we'll only write x equals, solving for x. For systems of equations, we need two numbers. We need a point, an x value and a y value. So to find that solution, we can always graph both of the lines, take a look at the graph, find that intersection point, and we write down that intersection point as the solution. The solution to a system of equations is the intersection of their graphs. I want to take a look at a special case. So what if we had two graphs, let's say y equals x plus 2 and y equals x. So two graphs, and here you might notice that our two graphs have the same slope. So they both have a slope of 1. In other words, if both of our graphs have a slope of 1, that means that they're parallel lines. So both of these have a slope of 1, which means they are parallel. So if we were to graph both of these lines, which we'll do right now, here's x plus 2. And then here is y equals x. Because they're parallel, these two lines will never intersect. Definition of parallel lines is lines with the same slope and lines that will never intersect. They're always going to be the same distance apart. If they never intersect, that means that we don't have an intersection point. So when trying to solve this solution, we can't find that intersection, so there's no solution. So when we have parallel lines and we're asked to solve a system of parallel lines, that means that there is no solution to that system. So that is a special case. Finally, if you're asked to solve a system and you're given the same line, for example, if we had y equals x plus 1, and maybe you're given 2y equals 2x plus 2. So notice for this bottom one, if we divide everything by 2, we end up with the same equation. If we have the same equation, then they'll just overlap when we graph them, which means that there's an infinite number of solutions. Any point is going to work for both of them because it's the same line. So in that case, if we have the same line, then we say that there are infinite solutions. So two kind of like special cases when solving systems of equations.